Welcome to Chapter 1, Essential Ideas in Chemistry, covering sections 1.2 through 1.6 of OpenStax Chemistry 2E. Section 1.2 covers the phases and classification of matter. Matter is anything that occupies space and has mass. The three states of matter are solid, liquid, and gas. A fourth state, plasma, is a gaseous state with charged particles. The law of conservation of matter states that the total quantity of matter remains unchanged during chemical or physical changes. Matter is classified into pure substances and mixtures. Pure substances are elements and compounds, while mixtures are heterogeneous, meaning non-uniform, or homogeneous solutions, meaning uniform. Atoms are the smallest particles of an element, and molecules are two or more atoms joined by chemical bonds. Physical properties, like density and color, are not associated with a change in chemical composition. A physical change alters state or properties without changing chemical identity, such as melting wax. Chemical properties, like flammability, describe the ability to change into another type of matter. A chemical change produces different types of matter, such as rusting iron. Extensive properties depend on the amount of matter present, such as mass and volume. Intensive properties, like temperature and density, do not depend on the amount of matter present. The periodic table groups elements based on similar properties, separating them into metals, nonmetals, and metalloids. Section 1.4 covers measurements. Every measurement has three parts: a number, a unit, and an inherent uncertainty. Scientific notation is used for very large or small numbers. SI base units include meter for length, kilogram for mass, second for time, and Kelvin for temperature. Common SI prefixes include kilo, centi, milli, micro, and nano. Derived units are combinations of base units. Examples include volume, measured in cubic meters or liters, and density, which is mass divided by volume. In section 1.5, we distinguish between exact numbers, which come from counting or definitions, and uncertain numbers, which come from measurements. Significant figures are all digits in a measurement, including the uncertain last digit. There are specific rules for determining which digits are significant. Rounding rules vary based on the mathematical operation. Accuracy is how close a measurement is to the true value, like hitting the bullseye. Precision is how close repeated measurements are to each other. Ideally, measurements are both accurate and precise. Section 1.6 introduces the mathematical treatment of measurement results. Dimensional analysis, or the factor label method, treats units like numbers that must cancel appropriately. Unit conversion factors are ratios of equivalent quantities used to perform conversions. There are three temperature scales: Celsius, Fahrenheit, and Kelvin. Kelvin is the absolute scale. We use specific formulas to convert between these three temperature scales. In summary, we've reviewed the states and classification of matter, physical and chemical properties, extensive and intensive properties, the essentials of measurements and significant figures, dimensional analysis for unit conversions, the difference between accuracy and precision, and temperature conversions.